Hello everyone, welcome back. In this week's lesson, we're going to be talking about colors and textures. In other words, so far, everything we've done pretty much has been kind of black and white. We're going to talk about different methods that we can use to bring in colors into our sketches, doing it so in a structured way, and also experiment with textures, right? The way that we choose to draw, much like if you draw on paper and you use different pens, different markers, and so forth is going to influence the texture of the end result. We can apply similar ideas when we are drawing with code. So we're going to talk about these concepts, and we are going to be using the program we built last week as a starting point, so we don't have to build something from scratch. Just as a refresher, the program we built last week was this Perlin noise field in which agents, these little squares here, we've called them agents. They're simply little objects that have a position, a velocity, and an acceleration. And we run a basic sort of physics-inspired simulation. They move around this field, and their acceleration is being influenced by a Perlin noise field, a field of vectors kind of underneath their feet. So we're going to use this program. If you haven't watched the previous lesson, just go back and watch week 3. We're going to build on that, and we're going to add some color and texture to this program, and we'll talk about a number of different strategies to do this. But first, before we dive into colors, let's add a couple of things to our sketch here, to our program, that are going to make our lives a little bit easier when we're experimenting. We'll add a couple of interface elements, and we will give ourselves some keyboard shortcuts. Okay. So first, one thing that we might want to add to our UI here is the ability to maybe show the Perlin noise field. So right now in this version of the code, I have this as a commented out line on line 32. And there it is. And this is the field, right? If we zoom in, we can see that the vectors, the difference becomes smoother. And if we play with the friction, if we lower this number a little bit, we can see our particles are kind of flowing along the field. So it might be nice when we're experimenting to be able to see like what our zoom level is, right? So that we know what we're dealing with. So let's add this option to toggle the Perlin field to our UI. So with that GUI, you can add numbers like this, but we can also add true or false values. For example, we could create an attribute in our settings object here. Let's call it show field, and we are going to set it to false by default. Okay, and then we are going to add to our GUI. We're going to add from the settings object something called show field, and we don't have to put anything else after because this is a true or false value. If I run the sketch, you see that now we have a little checkbox we can use. And then what we can do is make use of it in our code. So we're going to look at settings.showField, and we will use an if statement here to say if settings.showField is enabled, we will show the Perlin field, and otherwise we won't. Okay, so now we have a way to kind of turn this on and off as we are messing around, and we can turn it back off. Okay. The other thing we're going to add is the ability to do the same with the background. Because sometimes it's nice if we want to see the traces that our objects are leaving, kind of create more of a drawing machine. It's nice not to have the background being erased every time. And sometimes we want it. So instead of uncommenting back and forth here, we are going to make this a condition of a variable based on a variable. So let's call this erase background. Okay, and by default, we will set it to true. For now, we can always change that. And we will say if settings.erase background is set, we will call our background command, and we will add a line to our interface here. We'll say GUI.add settings erase background. So we are always just using the same name as the fields we created in our settings object. So now I'm going to have the option to uncheck that, and now we can draw. Okay. Of course, if I start to show the field is going to build up over time, so I may want to erase the background, and we can play around with these options. So pretty neat. We will set the friction here to 9, and let's zoom in a little bit more. see what that looks like. Okay. All right. The other thing we're going to do before we talk about color is we are going to add some keyboard shortcuts to this program. And the reason why is because I want to be able to, let's say we set erase background and we unchecked it. I want to be able to press spacebar and just erase the background. So we're going to go at the bottom here and we are going to define key pressed. And we will say if key equals space, we will simply go and say background 0. Okay, so we're going to clear the background on spacebar just as a convenience. Cool. And in fact, maybe we will also set the erase background to be false as a default, because a lot of what we're going to be doing is drawing stuff. So we might as well have it set by default. And then finally, one thing that could be nice as well is the ability to just kind of pause the program. And we can do this as well with a key press, or I guess I could add a button up here, but let's do it with a key press. And I'm going to declare a variable just down here. I'm going to call it pause, and we'll set it to false to begin with. And what we're going to do is in key pressed, if a key is equal to P, so we'll use the P key to toggle our pause function. We're going to do two things. First is we're going to make the value of pause equals to the opposite of what it contains. So this is called what we're toggling the value. So if it was false, it'll become true. If it was true, it'll become false. And then we'll look at pause and decide if we're paused, called no loop, and if we're not, called loop. Okay? So just a useful little feature here where if I press P, I can freeze the sketch. Maybe I saw something interesting and I want to just pause it. So now we have the ability to do that. Okay. All right. So with this little bit of kind of housekeeping out of the way, let's talk about colors, because that's why we are here today. And we're black here. Perfect. All right. So if we wanted to add color to these agents, well, of course, the first thing we're going to need to think about is we need to add a variable inside each agent so that they can have different colors. Okay, so that should be our first step in our line of thinking. So let's take a look at where we would do this. So in the code, this is where we create our agent objects inside this create agent function. We create this temporary object here. We give it a number of attributes: position, velocity, acceleration, life. We give them a little nudge at the beginning just to make their movement a little bit more random and interesting. And then we return the new object. So if we wanted to give each agent a color, we'll simply just add one more variable inside the agent object. So let's call this color. And as a starting point, we could say color. We'll make a random color because I don't have anything else yet. Okay? We'll give them a random color. And once we've done this, always be careful here. Don't use a semicolon. Use a comma when you're declaring attributes of an object. I always make that mistake. And once we've created this attribute, we are going to go into our code that is responsible for drawing the agent. And we will say, let's say we're going to set a stroke based on agent.color. So now we've added a color attribute, right? So now we can access agent.color, and let's see what that will look like. Okay, so now our agents have different colors. And I haven't pointed this out, but remember in the sketch, when I hit play, right, we just as a little review, when I hit play, we initially in setup, we create 100 agents that just spawn from the center. And then as the program runs, if my mouse is pressed, I also can go and draw and create more agents. Okay, so just so we have something to play with. So now we have the ability to give each of our agent some colors. Okay? Now random colors will not get you very, very far. And the reason for that is this gets old very quickly. If you can get a little bit of everything, just like with pure noise, right, versus Perlin noise, not enough structure is not very interesting, and it's not aesthetically very pleasing. We could try to work around that a little bit. Usually you can quickly improve your random color generation by switching to hue, saturation, brightness, and then maybe you randomize the hues so that you keep, let's say, all bright saturated colors, and then you're still kind of always just getting the colors of the rainbow. And we want to be able to move beyond that. So there's a few different strategies that we can use. We could sort of try to computationally generate things like complementary colors, tertiary colors, things like this. You can play around with this if you're curious. If you switch to hue, saturation, brightness, you can simply add offsets to the hue to rotate along the color wheel, and you could experiment with that. But if we want to have a bit more kind of intentionality in our color schemes, there's sort of two main strategies that I like to use. One is we're going to create, and both of them are related. So the first one is we're going to simply just create a palette of colors to choose from. And then based on that palette, we're going to make some random selections. So what do I mean by a palette of colors? Well, it's simply going to be an array. Okay? And this array is going to contain a bunch of colors. Now we could try to make up some interesting colors on the fly, but usually I like to turn to one of many color palette generators that you can find online. If you do a quick search for color palette, you'll find some websites. As of shooting this, this is the top site here, coolers.co. And this one is pretty neat, actually. And let's explore some trending palettes, and I'll tell you why it's neat in a second. So let's say, so here's a bunch of color palettes that are popular. Let's say I like this one here. Okay, we'll pick the first one. One thing we can do on coolers.co is we can export this palette. So I'm going to click on export here, and it's going to give me some options. This is just a bit of a time saver. So if I select the code option, I will get things that I can copy and paste from, which is pretty handy. So I have some choices here. None of them apply directly to P5.js. The array option is the closest though. So we're going to grab this one. I'm going to simply, copy this, bring it over into my code and put this as the array here. Now we just have to make one change to this is we have to add the little hashtag symbol in front of all the colors here. That's because that's the format P5.js expects for the hexadecimal sort of like HTML style colors. And you see these now become colors we can change. So now I have an array that contains 5 different colors, right? We could then go into create agent over here. And instead of picking a totally random color, we could simply select something at random from the array. And we've already seen in the previous week, if we have an array and we want to make a random selection, we can simply pass the array to the random function, and we'll get a random selection out of it. And again, comma, not semicolon, because we are inside an object. So let's hit play on this. Now we can see we have like a more interesting color palette, right? Pretty straightforward. I mean, it's random still, right? But it, of course, it's now only one of 5 possible colors, and we've made sure that these colors look nice together, and we can easily vary the palette by simply varying the content of this array. So this is a very common strategy. We could also pull one of these colors if we wanted to for the background, or we could choose to leave one out and make it that become our background, and so forth. So very straightforward strategy. Just go to a color palette generator, find some interesting palettes of colors. There's tons of websites to do it in slightly different ways. Some of them quite fancy nowadays. We will even use AI to analyze images and extract colors palettes from there. Our second pathway to adding color to our sketches without having to manually specify a color palette is going to be bringing in an image and using the image as a source of inspiration, as a source of colors. So that's going to be sort of the second method that we might want to use. So let's go over that a little bit and talk about some of the things that we can do with this approach. So first is we're going to have to bring in some images. Now I went on some stock photo website and I found these 3 images. They're square aspect ratio just to make things easy here, and it's just of mountains. Okay, and this one's got an airplane wing in it. And they had just interesting colors in them. So we're gonna add these to our sketch if we want to be able to use them inside P5.js. The way we do this in the editor is we go in the sketch files, we upload a file, and then I'm going to simply drag and drop my 3 images onto here. It's going to upload them, and now I have access to them in my sketch. So pretty straightforward. Let's turn that over so we have some extra space. Okay, so before we can use an image, we have to load it. We have to create a variable. We have to load the image, and then we'll have access to it. So somewhere at the top here, let's say after the palette, I'm going to define a variable, and I'm going to call it img, short for image. And rather than loading it in setup, I'm going to implement P5JS as this thing called a preload function. And what preload does is it ensures that the things you load using the P5JS functions, things like load image, load sound, and so forth, will be all downloaded, ready to go before your sketch starts. Okay, there's always a bit of a delay in these objects getting loaded because we are accessing your sketch through a browser, through the internet. So this ensures that if I try to use the image, so for example, I'm going to load image1.jpg and I have image 1, 2, and 3. Okay, I have some options here. This preload ensures that by the time setup comes around, this image variable will be fully ready to go. Okay. All right. So now I have my image, okay, and we could use it just as a source of color because it's full of pixels that kind of go well together because it was a pleasant looking image. So what we could do here is we could go into create agent, and instead of using the color from the random palette, okay, we're going to leave it. We're going to leave it like this, but we're going to just go down here. We're going to override the color here. Use a color from an image instead. Okay. We're going to go and sample into the image based on the position of our agent. Okay, so we know that XY here is where our agent is getting created in the window. Now the location in the window may not match the dimension of our image necessarily. So we're going to use map to sort of create a relationship between the location of our agent and its corresponding position in the image. Okay? So let's create a variable. I'm going to call it ix for image x. We're going to map the x value of our agent. We know is between 0 and width because our agents are being created within the window. We're going to map this to a number between 0 and image.width. Okay? And we'll do the same for the y coordinate, except it's going to be mapped from 0 to height to 0.image.height. This is going to take into account the fact that our image might be bigger or smaller than the canvas. In this example, it doesn't really matter. It doesn't have to match. We're only using it as a source of colors. Okay? So let's, and then what we're going to do is we're going to say temp.color. Remember, temp is our little variable we created here to make our agent. We're going to make it equal to image.get ix, iy. Okay? So this is going to go into the image and sample a color, right? Depending on where the agent starts its life. It's going to try to be more or less in that same area. So let's see what that looks like. So now I'm going to get different colors. And just so we remember what image we're working with here, let's go and draw. And just at the top here temporarily, we're just going to draw the image. And I know it's a square. I'm going to just draw it as a small square so we remember what it looks like. Okay, so this is the image that we're working with. So we should have some browns at the bottom here, and we should have some light blues at the top because we have the sky, and then in the middle here we should have the mountains. And that can be actually pretty interesting because now that we're using an image as our color palette, if we use the position of our agents to grab colors from the image, the other thing we kind of get for free is we also retain some of the structural information from the image. In other words, if we draw with lots and lots of agents over time, which I'm doing right now, over time we're going to start to see a structure that resembles our original image emerge. Of course, the colors are all sort of smeared together in this particular little example here, but we're kind of painting with the original image structure underneath our feet here. So depending on how much, let's erase the background here, how much friction we have, like let's say we have not a lot of friction, right? These agents will not go as far. So we could start to recreate almost the original image, but with this completely new aesthetic on top of it, using the Perlin noise structure. So that can be something really interesting to play with, right? So we're retaining the structure of the underlying image, but what we're varying is where the agents are being created. And of course, if we vary the image that we're using, so if I load one of my other images, let's say image 2, as you can imagine, we will get a totally different color palette. So that could be a really interesting strategy to approach bringing colors into your sketch, right? Other than shopping for palettes online, you can shop for images that have interesting colors, and that becomes the colors of your drawing machine or your sketch. Now, what we're doing right now, remember, is we're sampling based on the position of the agent. So we are retaining the structure of the image. The sky is at the top, the grass is at the bottom. What if we didn't want to do that? We just want to treat the image as a bunch of colors. Okay? Well, we could do this also. We could just simply decouple the position of the agent with where we're getting its color from. Okay, so in fact, this is the easier scenario. Use a color from an image based on agent position. Okay. Alternatively, we could use a random color from the image, right? We could say let ix equals random image.width and let iy equals random image.height. Okay, so now we're just going to go anywhere and have completely mixed colors, right? So we're going to get a different result here, but we're still retaining the vibe and kind of the feel of the original image. Okay. Cool. Now, one thing that we can play with if we're using that approach is we can resize the image to sort of skew a little bit which colors remain. There are some rather fancy algorithms out there that will allow you to resample an image, like make it smaller in a particular way and emphasize, certain images or find the dominant colors and so forth. We're not going to dive that deep into this subject here, but one thing we could do, just to kind of do the budget version of that, is in setup, we could try resizing our image to vary the palette. Okay, and we can do this by doing image.resize. Now imagine we took this image with actually, I think right now probably is like 1,000 by 1,000 pixels. What if we made it into a small image that only has 5 by 5 pixels? Okay, something is going to happen in that process where the image gets rescaled, where some of the colors are going to get dropped and some of the colors are going to remain. And if we draw that image again now, right, we can see it's scaling it up because there's some blurriness. I'm drawing it 100 by 100, so when it's in fact only a 5 by 5 image. What I've done is I've cut down on the number of possible colors. Right, so now I only have 25 possible colors. We could go even further, right? We can make it a 4 by 4 image, and now we only have 4 possible colors. Still coming from that original palette. Okay? So that could be another way to use an image as a starting point, right? Or for example, maybe I'm going to switch here to image 3. Image 3 now gives me some blues. And then if we don't resize the image, if we use the original image, well, all of a sudden I can get some white in there, some grays, because now I have the full level of detail. Okay? So just simply the simple act of resizing your source image could be an interesting way to get different color schemes going, right? Either more complex or simpler, right? We could actually 4 by 4 is still a 16 colors. Sorry, if we did 2 by 2, that would be the extreme. Right now I have very few colors, but what if we went back to something like image 1, the one where we started with, right? Now we have 4 colors. When P5JS draws a small image bigger, it will do this interpolation where it blends the pixels. So, but in reality, we only have 4 colors, the 4 corners here in that image. And this is what image 2 looks like. So we get interesting palettes from the same image just by varying its size, varying its scale. So that can be a fun trick as well. Let's go back to image 1 here, and we'll stop playing around here in a second. All right, nice. Okay, so I think those are like the 2 main methods of bringing colors in I wanted to talk about. So either use a straight up palette, or get your palette from an image. And both of them have interesting possibilities. Of course, the straight up palette, you have a bit more control over the actual colors. If you bring in an image, it's a little bit more loose. but this can be a little quicker as well. And then it's easier. You can easily swap out different images to get different feels. And then the benefit of the image, of course, is that you can retain, if you want, right? You can retain structural information from that image, and maybe we'll explore that a little bit more at the end of this video, right? To play around with maybe sort of slowly revealing an image using the Perlin field. So some interesting possibilities there. All right. Now, let's talk about different strategies for textures. Now, already, just by virtue of how this sketch was created, we can see that we're drawing with these little squares here, and we are getting some kind of interesting texture out of that. Okay, but we're going to explore this with a little bit more intentionality and kind of go through some options that we have for playing around with textures. Okay, so in particular, we're going to talk about drawing lines, right? And then leveraging some of the JavaScript sort of hidden commands that we can use to draw things like dashed lines, add shadows, play around with our line thickness. So we'll explore some of the various options. And of course, we'll revisit this idea of drawing with shapes and maybe with a little bit more flexibility again. And also the concept of, we don't have to always draw the same shape over and over. We could have multiple shapes, or we could have a shape for a portion of the life of an agent and then a different shape at the end, things like this. So let's kind of talk about texture here a little bit and explore that. So as we go along, we're going to create basically like different versions of this render function so that we can backtrack and experiment a little bit with different approaches that we've run into. Okay. All right. Also, this would be a good time as well to give us maybe a few more options in our GUI. So for example, right now, all of our agents have a life of 100 to 120, after which they get discarded. So it might be interesting to be able to vary this a little bit. If we had a setting for the minimum and maximum, that will impact the kinds of things we can draw if our agents have very short lives or long lives. So let's give ourselves a setting for that. We are going to go into our settings here, and let's create a setting called minLife, and we'll say the shortest life you can have is 1, and maxLife. Actually, we'll go back to similar settings we have right now, but we'll be able to change them at least. So we'll make these into variables of our settings object, and then go and add settings minLife, and let's say we'll give ourselves a range from 1 to 250. And then we'll do the same for maxLife, and we'll have to keep in mind that we want to make sure min is always less than the max, but we can't enforce it through that GUI, but we'll just leave it up to us to make sure we remember that. And then in our sketch, when we create the agent, we're going to scroll to create agent here, and instead of using 100 and 120, we'll say settings.minLife, settings.maxLife. So now we could create like much shorter little stints here if we wanted to, or we could have a bigger variety of ranges. So just something interesting to play with. Okay. And then I guess before we get into the textures, the other thing I will do is, because there's a bit of preloading every time I run my sketch here, I'm going to temporarily just get rid of the image. And we will go back to getting our palette from this array here. So they're just different methods. I will leave the code here. I'll just simply comment it out. And we'll go back to getting our colors here from the palette. Okay. And we don't need to draw the image either, just because I'm finding it a little bit distracting. So let's comment it out. What's happening here? Line 29, I forgot to, oh, I cannot resize the image either. Okay, no problem. All right, so let's just go back to these colors for now. Now let's talk about textures. Already, because of the way we're drawing, we have these little squares here following the trail, right? So what we're doing to draw this square is we're translating to the agent position, then we're rotating based on the velocity, and then we're drawing a tiny little rectangle, already that gives us a certain textural feel to our program, right? Let's call this render square. And then we'll create a render function so we don't have to go and change the main draw loop. And then we will have our different options here. So we can have render square. We could create an alternative one here. Let's create a render point. Right? So depending on how we choose to interpret the agents, we're going to get wildly different results. Okay? Render point could be as simple as set a stroke based on the agent color and draw a point at agent.position.x, agent.position.y. And then in render here, we are going to say render point agent. And so we can change between them. And the idea here is we'll just have different functions with different styles of rendering that we can experiment with. And rather than overwrite the code each time, I will keep building separate functions so that by the time the program is done, you have a reference of the different things we tried. I forgot a parenthesis here. Let's hit play again. Okay. So now we're drawing the agents as points. Okay? And you can see that obviously, I mean, this stating the obvious here, but there's a big difference between drawing with squares and drawing with points, right? We get a totally different effect. This one in particular, like because the gap between each movement of the agent, because the velocity is high, is bigger than the space between the points, like we get these separated out dots, which give a really interesting, almost kind of like sandy texture. Okay. Now, this is simply a side effect of the fact that the points are moving faster, right? Let's say I increase the friction and made this slower, right? Maybe zoom in some more. Let's make even more friction. Okay, just to drive the point home here, I'm going to go beyond. Oh, I can't. That's okay. Let's allow this by making the range here bigger. Let's really increase the friction. See, now if I'm increasing the friction a lot, the gap between my drawings is smaller, and now we're getting them represented as lines, okay, which totally changes the texture and the vibe of this particular sketch. Now this was a nice texture, but we're getting it almost kind of by accident, because if I again increase the friction, now I can't get the lines, I can only get the points. So it would be nice if we were able to intentionally draw some lines and then affect how the line is being rendered, its rendering style, to achieve some of that textural pattern or textural styles. So what does that mean? Is that instead of drawing dots that happen to be far away from each other, I want to be able to connect these dots and draw continuous lines all the time. Okay? And we've explored something like this a little bit a few weeks ago when we created a step recorder for our simulation, right? So we would have access to every location our points had been to, and then we can connect the dots with a line, for instance. For this sketch here, we won't go that far, because if we tried to redraw every single path from scratch, it would actually be computationally quite expensive, and it would start to get very slow and a little bit frustrating to try to create with. So instead, we're going to just record the bare minimum information we need to draw complete lines, which is where the agent is located and where it was one frame ago. If we have that information, we can connect those 2 points with a line, and we can get continuous lines out of our agent's movement. And then we'll be able to affect those lines using the stroke weight and some other sort of hidden special abilities of strokes, at least in the 2D P5.js JavaScript rendering. So what we need to add to our sketch in order to explore this a little bit, let's get rid of this comment while I see it because it's unrelated, is we need to add a little bit more detail onto our agent object. So not only are we interested in the position, we need to remember where we were one frame ago in order to be able to literally connect the dots. So let's add one more variable. Let's call it, I'm going to use prev position for previous position, just make it a little bit shorter to type. This is just going to be, let's start with a vector that will be identical to our position. Okay, so we need this to be a vector. And again, I'm going to put a comma here. And then once we have this, we're going to go into move. That's the code that's moving our agent around. So we have a function called move somewhere up here, or maybe it's down here. There it is. And what we'll do is before we change the position here, before we do anything else, we're going to remember our position in the previous position. Okay. Now we have to be a little bit careful here when we're assigning vectors to other variables. If I simply wrote something like agent.position, right, this is going to make previous position equal to that object. Okay, so it's not going to create a copy. It's going to make it the same variable so that as we change the position, the previous position will also get updated because both variables are going to be pointing to the same data inside the program. What we need to do is just simply create a copy. So we don't want it to be the same object. We're going to create a copy of the position. That's going to make a brand new variable, make it equal to the previous position. And then our little algorithm is going to update the agent's position. And what we're going to be left with is the new position and the old position, right, in two different variables. And that's something we can make use of. So instead of rendering a point, maybe we will, let's create a render as a line. Okay. And let's comment out renderPoint. Let's call it renderLine instead. So what does it mean to render as a line? Well, we'll set the stroke color based on the agent color. And we will draw a line between agent.position.x, agent.position.y, and its previous position. So we'll say agent.previousPosition.x, agent previous position.y. Excuse me. And that should give us a line. Sweet. So now, no matter how fast we're moving, right? Even if our agents are moving really, really, really fast, we're always going to be getting some actual line segments, some continuous line segments that we can refer to vary the overall texture and look and feel of our sketch. Okay? Very nice. So already we can see we're getting this, it's the same framework. We're just changing the texture of how we're going to interpret it. So we have color and we also can play with textures. Now, because we're drawing this as a line now, this is opens up some interesting possibilities. For starters, we could change the stroke weight. So we could decide to draw thicker lines, for instance. So this is a weight of 2. We could go much more extreme, right? We could draw thicker lines here. We could decide to vary the line thickness, right? We could make it based on the life of the agent, right? We could use map here to make the stroke thickness, or we could, when we create the agents over here, we could decide to give them each a different line thickness if we wanted to. Yeah, we could create thickness, make this random, maybe between 1 and 15. Okay. Again, and now we have an attribute, a property that we could leverage when we are drawing our agent here. We could say thickness, and now we can have some variety, right? We'll have some thin ones and we'll have some thick ones as well. So that's something else we could play with. We can even go pretty extreme actually with the line thicknesses, and we're going to end up with almost like ribbons, right? So that could be really interesting way of generating textures. And when we do this, we're also going to start to get sort of like accidental textures from the objects kind of overlapping and being drawn on top of each other. Okay? Because we are drawing them over time, this create like when two of them follow the same path, right? Here we're getting these kind of interesting accidental textures. If we wanted to get rid of these, we would have to then take the approach of recording every single location that our object has been to, which we've seen in week 2. And we could build that into our agent object if we wanted to. We could have an array, maybe we call it a trail, and every time the agent moved, we would add the position to this trail, and we could recreate the full trail from scratch, and that would get rid of these accidental textures. But I actually quite like these accidental textures. Just so in this case, I actually don't mind that they're there, but it's worth pointing out that because we are just drawing over time, right, by not erasing the background, um, we're kind of getting this weaving effect, which can be cool. Some other things we can do with a line in P5JS is we can play with the stroke cap. And let me refresh my memory here, the different options. So by default, the stroke cap is round, but we can also use a square cap. And what that means is that now we can have lines that will look like this, where the end of the line is going to be square. Now, again, in this particular instance, because we are drawing separate line segments, right, we are getting these accidental textures in a way. If we wanted to get a perfect ribbon, right, a perfect ribbon, we would have to use the approach I just described. But for this example, we're not going to get into that. But more texture is always can be a good thing to get just a little bit more detail into our sketch. The last option is project, but to me it looks a lot like a square. Yeah. So you can change the stroke cap, and you can also change the stroke joints. And this will have not as much of an impact if you're not drawing a fully continuous line. If you're just going from previous position to current position, the bends don't really matter because we end up drawing individual line segments here. So that's another way that we can affect texture. And so let's go back now to, we're going to ignore the thickness attribute for a while here. I'm just going to comment it out, and I'm going to go back to drawing some thin lines. Okay? Another way that we can affect the line segment is we can draw a dashed line in JavaScript. Now, this is a little bit of a secret function because it's not directly documented as part of the P5JS reference. It's going to require us to access the underlying canvas element object, the drawing context that we are drawing our stuff in. That's a little bit more just JavaScript based, not P5JS. And on that drawing context, we are going to use a function called setLineDash. Okay? Now, the way we access this secret object is we are going to simply say drawing context. Okay? So there is a built-in variable. It's just part of P5. This is what P5 is using under the hood when we call stroke and point and circle and rectangle to draw the shapes. It's using that HTML drawing context canvas object to draw the shapes. And we can access some features of it directly by just calling some functions of that object. So that object happens to have a set line dash command. And the input parameter to the line dash is going to be an array. And once you see how it works, it's pretty self-explanatory. So this array is going to take some values, and let's try a 4 and 4. Okay, and we'll talk about what these numbers are in a second. So if I set a line dash here of 4 and 4, and keep in mind, this is going to affect every single shape that you draw from at that point on. So not just the lines, but it's going to affect rectangles and other shapes. Okay, so you can use that to draw dashed outlines for circles and any kind of shape. So any lines being drawn by P5 will be affected by this drawing context. So this is saying draw 4 pixel wide segments, then have a 4 pixel break, then 4 pixel segment. Okay? Or we could make something like, we could change, doesn't have to be balanced. We could say draw stretches of 12 and then have a little bit of a break 4. And because our line segments actually are not that long, we don't really see the result. Okay, so that's a bit too long. But we could say maybe we'll do something like 1 and 4, right? So now we have different we have a different style of of dashes, right? So this is going to be for the little line segments that we draw. We can specify the first number is the amount of pixels, and then the second number is the size of the break. Or we could do something like 3 and 1 to have more lines with like shorter breaks. Okay? And all of these, when they start to build on top of each other, will give us some different interesting results, okay, for textures. So that can be fun to play with. You can also come up with like longer sequences, like you could have a 2, then a 1, then a 3, then a 4, something like this. So you can come up with longer patterns of dashes if you want to. That might be more interesting if you're drawing bigger shapes like squares or circles, or drawing longer lines using begin and end shape and using vertices in between. But remember, right now we're drawing some shorter line segments. So if we make our line dash too long, we're not going to see the results. Okay? And this will apply to the thicker stroke as well. Okay? Yeah. Let's set a round cap. And we'll set a longer dash maybe. So in our case, that's going to result in a bit of a difference here in terms of the overlapping textures. So the line dash here, because we're drawing short line segments, a little bit more effective. But that allows us to kind of go back to this texture we had before, which was kind of alternating, maybe just drawing kind of like dots, or maybe creating more space between dots, right? 1 and 3. Kind of like where we started with, except now this is no longer totally dependent, right, on the friction, right? We can have a little bit more control over these. Although now that I say that, it does still affect it a little bit because we are drawing such short line segments. The dashes don't really appear as much. But maybe in a follow-up to this, we'll talk about how we would do the full trail here if we were interested in that, so that we could draw long line segments, short line segments with the dashes if we wanted to. All right. So we can play around with line dash just to get some interesting textures, and just to vary, from not having dashes to having it, we can influence the outcome and the result. Another way that we can use as well to influence our texture is to play with alpha values. So in renderLine, if I go and maybe we'll set a transparent, semi-transparent alpha value here. Oops. Right, it won't let me do this because I'm passing a string here. So let's talk about how we would add alpha values to these colors from the palette. So I can't use the color directly because now my color is a string. It's not a color object. So that's easy to work around. Let's go into our renderLine function. And if we wanted to add alpha to something that was like a string-based color, we could do something like so. We're going to set a temporary variable. We're going to create a color from agent.color, and then we will set the alpha on that color. So the difference between the two is that agent.color is a string. So it's like double quotes with like an hexadecimal code in it. Whereas the C variable here is a P5 color object. And the P5 color object has a few functions you can use on it, including setting its alpha value. So that's another really powerful way of influencing textures, is by playing around with the alpha value. That could be something we might want to make as a parameter of our UI. If we lower the alpha, right, it takes a little bit longer for the lines to emerge, for the structure to emerge, but also it creates some bright areas, some darker areas, and that's another way that we can use to play with texture over time. Okay. So let's look at one more example of how we can play around with texture or textures. We're going to kind of combine where we started with rendering as a square, but we're also going to leverage the fact that now we have the previous position of our agent, okay? And we're gonna create kind of these little, almost like tendrils, where we're gonna have draw a square shape for a portion of the life of the agent, and then when the life is over, we're gonna drop a circle or something like this. So let's create one more draw render function. Okay, I'm going to call it tendrils just because that's what it's going to remind me of. But this is just kind of a made up thing. Okay? So as a starting point, we're going to use something very similar to our render square. Okay? So let's go back to that. Except we're going to do a difference here. Instead of setting a stroke, we're going to set a fill for the using the color. Okay. I'm going to set a fill color, and now my stroke is white, okay, which kind of obscures my color palette a little bit. So instead of using white as a color for the outline, I still want to retain the outline because that's going to add a little element of texture in there. We're going to manipulate the color that we have, and we are going to create either a brighter or darker version of the color that we have to play with, and then use that as the outline. Okay? And here's how we're going to do that. I'm going to set the stroke as either a brighter or darker version of this color. Okay? So first, we're going to do like we did before. We're going to make like a temporary actually, we're not going to do that. We're going to create, let's extract the hue, saturation, and brightness from our color. Okay, and we can do this in P5. We're going to say hue, agent.color. Let's extract the saturation, agent.color, and let's extract the brightness. So these commands we can use, we give it a color, and it will extract just an individual color component. And then we're going to basically make it brighter. So now that we know the brightness, we're going to say just make the brightness equals to 1.5 times what it was already. Now this might exceed 255. Okay, so there's a possibility it might get too high. So we're going to add a modulo operator. So modulo allows us to wrap around if we exceed a certain number and then go back to 0. So we'll put a modulo 255 here. So that means if we started with a dark color, we're going to get a brighter version. If we started with a bright color, we're going to go and loop around back to dark, and we'll get a darker version. And then we're going to assemble these components back into a color. We're going to temporarily switch into color mode HSB. We're going to say set the stroke to be HSB. And then we're going to jump back into RGB color mode because the rest of our colors are in RGB. Okay. Let's see what that looks like. So now it's a little bit hard to see, but we have outlines that match the color that we're using for the fill. They're just a variation. They're either a little brighter or darker. And that way we can retain the outline for texture, but not have to be overwhelmed with the white. The other thing we're going to play with is we're going to make it so that, so right now we're just drawing a bunch of squares, one behind the other. But I would like to scale these squares according to the distance between 2 points in my line, or between where I am and where the previous point is, just so that we can fill in those gaps so that we don't have these gaps here. So we're going to calculate this as the distance. Let's call it D. We're going to take the static version of the distance function. And distance allows us to take two vectors, 2 points, and it's going to measure the distance between them. So we'll say measure the distance between agent.position and then agent.previous position. And once we know this distance, we're going to use it to set the size of our square. Okay. Let's take a look at that. So now we can see I got rid of the gaps a little bit. And more interestingly, like if we get rid of most of the friction, we make our agents go really, really fast now. You can see that the path is like the shapes are also getting bigger, right? Because now there's a bigger jump between each point, and the squares are kind of filling in the blanks here. So that's kind of neat. And we could lower their life a little bit. Let's erase the background, give them a very short life maybe. So we have these like slow little bursts. Okay. So we're still playing with the same framework, right? All we're doing is changing how we're rendering those agents, and in the process, getting some very different textual results. Now, the other thing we could do here is, in addition to drawing these paths using shapes, so here I'm drawing a series of squares, and we could also decide, maybe we're going to do something different based on if the square is still alive or if it ran out of life, right? Maybe on its very last step, instead of drawing a square, we're going to draw a circle, just to create maybe the extremity of our little kind of tendril shape. So we could say if agent.life, so remember we have in our create agent, right? We have a life, right? So we can look at that number and decide to do something based on that. So in render tendril here, where was I? We'll say if agent.life is greater than 0, we're going to draw a rectangle. Else, we're going to draw a circle. And maybe we'll make that circle 3 times the size of the box. And let's play again with those settings a bit. Give them a short life so we can see what's happening. And erase here. See? So now I'm drawing one shape for a while, and then at the end here, I'm going to draw another shape. So that can be another interesting way of thinking about introducing texture, right? We can vary the types of shapes that we're using and use them just not completely randomly, but here I'm using it strategically, specifically at the end, right, of one of those lines. I'm popping a circle, and then that's giving me a particular look and a particular sort of texture and look and feel. Yep. So that could be another thing to play with. And let's see what it looks like if I emphasize here the square a little bit. I'm going to make it times 1.5. And let's make them longer. Yeah. So I kind of like this as well. So now I've made the square a little bit bigger than it's supposed to be to cover fully the distance. So now there's a little bit of an effect here where, some of them are a little bit bigger than the previous one, so it creates a little bit more of a variation. So again, anything that we can do to vary how things are being drawn will vary the end result and the texture elements that we get. Okay. Another thing I want to point out real quick is with the drawing context, the drawing context that we used in renderLine, right? So we can still we could still apply a line dash if we wanted to. Let's say we could do this here. We could apply a line dash to our shapes. It's going to get a little bit harder to see, but the outlines are going to be dashed here, theoretically. We can also apply a shadow to shapes that are being drawn by the engine. So yeah, we can see some dashes now on the outlines, right? So kind of like a stitching pattern. So just to show you that the line dashes apply to all the lines, right? All the outlines, not just when we're drawing lines. If you draw a circle or a rectangle that has an outline, you will get those dash patterns. We can also unlock some drop shadows that are part of the 2D just browser renderer. And the way we activate those is also via the drawing context. We could set a shadow color. So that's going to be, I'm going to use black here. We can set a shadow blur. And that's going to be the amount of blurriness we get. Let's start with 5. And then we'll set an offset for the X and the Y. So this is going to be the amount that the shadow is offset. So let's go with maybe 5 also, offset X, and then offset Y. This is another neat thing to play with if you want to experiment with textures. You can create, increase the, You can use the built-in sort of drop shadow feature of the 2D renderer to create shadows under your 2D elements. And of course, these shadows can get like pretty intense. I'm going to exaggerate here, go with like a 15 blur radius and a 15 distance. So that might be a little bit much, but just to show you that we can add shadows, and we can also use that as a way to create depth. And especially when you're layering a lot of shapes, so that could be a fun thing to play with as well. Or you can create, very sharp shadows, and you can play with the offset. If you make it negative, it'll be to the left. If you make it negative on the Y, it will be at the top. So we can play with this, and these shadows, it's going to be a relationship between the offset and the amount of blur that you get. So that can be another way of quickly adding some textures to your sketches. And of course, the last thing we're not going to do in this example because we're kind of running out of time here, but the other thing you could play with is literally, instead of drawing shapes, you could think about drawing actual images, right? So you could load image assets, use them to do your drawing, to paint with. And that could be an interesting way also of transforming the generative framework you've created, just without having to rely on geometric shape. You can do hand-drawn assets that you create, and then use those to populate, to follow the trails, and use those to kind of to draw. And that could be a really interesting way of creating very detailed, intricate textures also. All right. Very neat. Okay, so this video is getting a little bit long already. We're going to do just a really quick recap, and then we'll leave it at that. So what we talked about today was two main ideas. Now that we're kind of know how to create a framework that has moving elements, that can generate some sort of drawing system, the game essentially becomes interpreting that framework. And we saw that we can do this in a number of ways, just in terms of the motion and applying different strategies for motion, but there's also a lot of creativity that can happen with colors and textures. We saw that we can bring in color palettes, or we can draw from an image to get our color palettes. And then we also explored this idea that we can vary the texture of what we're drawing simply by playing around with the shapes of what we're using to draw our elements. And we did a few experiments. In this lesson, we used just straight up points. We used the squares from the previous week. We talked about drawing continuous lines and then affecting the lines using line dash. And then finally, in this last version, we're combining some of these ideas using rectangles and circles to create these sort of like tendril-like shapes. Also using shadows and using simple color manipulation here to derive either a brighter or a darker version of our color for the outlines. All right. So yeah, some stuff to experiment with. In the final sort of drawing machine portion video of the course next week, we're going to talk about behaviors a little bit more. So I'll see you next week for that. Take care.